Hello everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, our lesson is the meaning and properties of a rectangle. Also, we will be discussing the conditions for a parallelogram to be a rectangle. Okay, when we say rectangle, this is a quadrilateral whose four interior angles are all equal in measure. Okay, we already know that the sum of the four interior angles of any quadrilateral is 360 degrees. So if we will divide this one by 4, then that means each interior angle of a rectangle is 90 degrees. So this is 90 degrees, 90 degrees, 90 degrees, and this angle is also 90 degrees. Okay, now, what are the properties of a rectangle that you have to understand and remember? Okay, this figure is a rectangle. Okay, according to this first property, it has all the properties of a parallelogram. So if we are going to recall the properties of a parallelogram, okay, opposite sides are equal in length. Okay, but in here, or in this rectangle, we cannot actually say that this side is equal to this side or this side is equal to this side. It's not indicated here that the opposite sides are of equal length. Okay, what are the other property of a parallelogram? Okay, opposite angles are of equal measures. So if we're going to take a look at this rectangle, yes, opposite angles are of equal measure. So this is 90 degrees. The opposite angle is 90 degrees. This is also 90 degrees, and the opposite angle is also 90 degrees. Okay, that's why rectangle is also a parallelogram because it has all the properties of a parallelogram, or we can use the properties of a parallelogram. Okay, what about the second property? According to this one, the length of two diagonals are equal. Okay, let's prove that the lengths of two diagonals are equal. If we're going to draw the two diagonals, so this is our first diagonal and second diagonal. So these two diagonals are of equal length. Let's prove that one. When we draw these two diagonals, we have this triangle ABC. Okay, triangle ABC and DCB. So triangle DCB. These two triangles are congruent triangles. So ABC, this triangle, and DCB. DCB, this triangle. Okay, I just mentioned that these are congruent triangles. Okay, to prove that one, this is 90 degrees, 90 degrees. So 90 degrees, 90 degrees. Okay, this side is the same length with this side. Okay, this is a right angle. And this side is equal length to this side. So we have here SAS, congruence. So if these two triangles are congruent, then it means this side of this triangle is equal to this side of this triangle. So these are the diagonals of this rectangle. That's why the length of two diagonals are equal in length or equal in measure. Okay, now, we will be talking about the conditions for a parallelogram to be a rectangle. So in these figures, this is a parallelogram and this is our rectangle. Okay, as you can see here, opposite angles are of equal measures. This is opposite to this one, so equal in measure. And this is a rectangle. So when we draw these two diagonals, from here to this point is just equal length from here to this point. Also equal from here to this point. This is equal also from here to this point. Okay, the first condition is one of its angle is 90 degrees. So even if there's just one given angle and that angle is 90 degrees, then we can say that that is a rectangle. Okay, how's that? Or let's explain that further. One of its angle is 90 degrees. So if it's mentioned or if it's given that this is 90 degrees, then this is already a rectangle. Okay, why? Remember, if we will add this angle plus this angle, it must be equal to 180 degrees. So if this is 90 degrees, then that means this is also 90 degrees. Or if we are going to add this angle and this angle, it must be equal to 180 degrees. So if this is 90 degrees, then that means this is also 90 degrees. So even if there's just one given angle and that angle is 90 degrees, then that's already a rectangle. Okay, for the second condition, the length of two diagonals are equal. So it's like what I've mentioned. If it's a rectangle, then when we draw the two diagonals, the length of that two diagonals are equal. If it's in a parallelogram, this diagonal is not equal to this diagonal. But for a rectangle, these two diagonals are equal in measure. That's why from here to here, this point, this length, they are of equal length. But here, from here to this point, and this point to this point, equal in measure. This one is equal to this one. Okay, now, let's give an example by answering this concept check question. In rectangle ABCD, we will let O be the point where the two diagonals intersect. We will find the values of X and Y. So it's given that this figure is a rectangle and O is the point of an intersection of these two diagonals, or this point O. Okay, we will find the values of X and Y. So X and Y. Okay, since this is a rectangle, so that means the two diagonals are of equal length. So if from here to this point is 4 centimeters, that means from here to this point is also 4 centimeters. Because this point O bisects these diagonals into equal length. So X is also 4 centimeters. So it means this length is 4 plus 4, so Y is 8 centimeters. Okay, now let's answer the following problems. So this is our first problem. In rectangle A, B, C, D, or this rectangle, the diagonals intersect at point O and angle OCD is 65 degrees. We will find the measures of angles X and Y. So this is the point where these two diagonals of this rectangle meet or intersect. So that's point O. We will find the measure of X, angle X and Y. Okay, it's given that angle OCD is 65 degrees. We're looking for this angle and this angle. Since this is a rectangle, then all the interior angles are 90 degrees. So, including this angle. So, this is 90 degrees. So, to find the measure of angle X, we have here 90 degrees minus 65 degrees. And that would be equal to 25 degrees. So, it means angle X is 25 degrees. Okay, now, what about angle Y? Angle Y belongs to this triangle BOC. And since this side is equal to this side, because take note, okay, this is like the intersection of this diagonal. So this line is just equal to this line. So it means triangle BOC is an isosceles triangle. So if this is 25 degrees, then that means this is also 25 degrees. So to find the measure of angle Y, okay, 180 degrees, that's the sum of the three interior angles minus this sum of these two angles, 25 and another 25. So minus 50. So it means angle Y is 130 degrees. So this is 130 degrees. Okay, what about this last question? We are going to select all the conditions under which parallelogram ABCD becomes a rectangle. Okay, let's take a look at this first figure. So it's just indicated here that this angle where these two diagonals intersect, this angle where these two diagonals intersect is 90 degrees. Okay, we didn't say, or I didn't mention in our discussion a while ago that when these two diagonals meet, then there will be right angle form here. So this is not correct. Okay, what about the second figure? So as you can see, it's just indicated here that this one angle is 90 degrees. So it means this is a condition for a parallelogram to become a rectangle. So even if the given is just one angle and that's 90 degrees, then that's already a rectangle. Okay, for figure number 3, okay, it's indicated here that this diagonal is 7 degrees. This is also 7 degrees. So again, the two diagonals are equal in length. So this is correct. Okay, for number 4, this angle is 40 degrees. This angle is 50 degrees. These angles are formed when we draw this diagonal. Okay, now, when we draw this diagonal, there is this triangle ABC and this ADC triangle. So, this is 40 degrees, 50 degrees. If we will get the measure of this angle, this is also 40 degrees. Okay, why 40 degrees? Because when we draw this Z shape, that means these two angles are alternate interior angles. So they are equal in measure. So same reason with this angle and this angle. So this is also 50 degrees. That is because these two angles are alternate interior angles. So 40 plus 50 is 90. This is also 90. So same condition in number 2. So it means figure number 4 is correct.